Defining one-to-one functions. A clear explanation. In mathematics, functions describe relationships between quantities. They help us understand how one set of values relates to another. One special type of function is the one-to-one function, also known as an injective function. Imagine you have a basket of unique apples and a group of friends. Each apple is different from the others. You give each friend one apple, ensuring that no two friends get the same apple. This represents a one-to-one function. Each apple, input, is paired with only one friend, output. Each apple is given to a unique friend, and no apple is shared between friends. No two friends receive the same apple, ensuring a unique pairing. In mathematical terms, each distinct element in the input set, domain, maps to a unique element in the output set, codomain. This ensures that every input has a unique output. This unique mapping is a fundamental property of one-to-one functions. It helps in understanding the structure and behavior of mathematical relationships. It has important implications, especially when reversing the function's operation. Understanding one-to-one functions is crucial for grasping more complex mathematical concepts. Illustrating the concept simple, everyday examples. These examples help us grasp complex ideas by relating them to our daily lives. Let's solidify our understanding with relatable examples. By connecting abstract concepts to familiar scenarios, we can better understand their applications. Assigning each student a unique ID number illustrates a one-to-one function. This means each student is paired with a distinct identifier. Each student, input, has one unique ID, output, and no two students share the same ID. This ensures a clear and distinct identification system. Another example is the relationship between a person and their passport. Just like student IDs, passports are unique to each individual. Each person is issued one unique passport, ensuring no two individuals possess the same passport. This is crucial for international travel and security. However, not all functions are one-to-one. Some functions can map multiple inputs to a single output. For instance, squaring a number, both -2 and 2, when squared, result in 4. This is an example of a many-to-one function. This violates the one-to-one principle, as two different inputs map to the same output. Understanding these distinctions is key in mathematics and real-world applications. Key properties of one-to-one functions are essential in understanding their behavior and applications. One of the most important tools for this is the horizontal line test. The horizontal line test is a simple yet powerful method for identifying one-to-one functions graphically. To perform this test, draw horizontal lines through the graph of a function at various points. If any horizontal line intersects the graph at more than one point, the function fails the test and is not one-to-one. Conversely, if every horizontal line intersects the graph at most once, the function passes the test and is one-to-one. This visual confirmation is crucial for verifying the one-to-one property of functions. Another crucial property of one-to-one functions is their reversibility. This means we can find an inverse function that undoes the original function's operation, effectively reversing it. This reversibility is a direct consequence of the unique mapping in one-to-one functions, ensuring each input maps to a unique output. Section 4. One-to-one versus onto functions. Understanding the difference. One-to-one functions emphasize unique mapping from input to output. Onto functions, surjective functions, ensure every element in the output set is mapped to by at least one element in the input set. For example, every seat in a concert hall must be filled, representing an onto function. One-to-one functions guarantee uniqueness, while onto functions prioritize covering the entire output set. Section 5. Practical applications solve problems. Let's apply our knowledge to solve some problems. Consider the function fx equals sine 3x, 1. To determine if it's one-to-one, assume fa equals sine fb for some inputs a and b. This means 3a, 1 equals sine 3b, 1, simplifying to a equals sine b. This confirms fx is a one-to-one function. Now consider gx equals sine x2. Both -2 and 2 when squared result in 4, violating the one-to-one property. Therefore, gx is not a one-to-one function. Section 6. The importance of one-to-one functions in mathematics. One-to-one functions are crucial in defining invertible functions, essential in calculus, algebra, and cryptography. In calculus, inverse functions are fundamental for defining derivatives and integrals. In algebra, they play a vital role in group theory and ring theory. In cryptography, they ensure secure encoding and decoding of information. Understanding one-to-one functions equips us to analyze, manipulate, and interpret mathematical relationships across diverse fields.